In this video, I will review medical malpractice case. We have a file of 118 records of patients who sued doctors, amounts paid to each patient, and then severity of the case from 1 to 9, 1 being the lightest, emotional stress, and 9 being the most severe. Age of the patient, if there was a private attorney on the case or not, marital status of the patient, specialty of the doctor, type of insurance, and gender. Our goal is to visualize the data and see if we can find a significant relationship between the amount paid and any of these factors. First, start with distribution of amount, how it looks like. So we go to distribution, amount, and click OK. We can see most of the payments are concentrated in bracket of 0 to 100K, and there are a few cases beyond 200,000, mostly outliers. We can easily see the quantiles, maximum over 900K, quartiles we can easily see them. The mean payment is about 91,000, and other summary statistics. Looking at the red bracket, the densest 50% observations, you can see most of the payments are concentrated on the lower end of the bracket of 100K. I'm saving this distribution as a script to data table. It's called distribution amount, and now we do a distribution of age. It's very close to normal. You can see the second quartile very close to the mean. So the middle of the diamond represents the mean, and they're very close, almost symmetrical, not completely normal. And we can see the distribution. The average age is about 42.8. I will save this script as distribution of age. Next, we'll look at distribution of gender, a nominal value. So we can have the histogram of frequency, and we can find that 71 out of 118 cases are female patients, 47 are male, so almost 60% female and nearly 40% male. For multi-level categorical variables, we can use Pareto chart and pie chart too. Here I'm going to use Pareto plot and pie chart for insurance. Go under Analyze menu, Quality and Process, Pareto plot, insurance into Y or cause, and we'll make a Pareto plot. Pareto plot is frequently used in quality control. Here we can see the frequencies are stacked in columns, and they are sorted from the most frequently observed private insurance, sorted to unknown, Medicare, Medicaid, no insurance, and workers' compensation. The two vertical axes, the left side is count, the right side is percentage, cumulative percentage. The advantage of the Pareto chart is that at any point we can see the cumulative frequency as a percentage. For example, private and unknown, both together. We can look at the point that represents both together cumulative, and we can see that's above 70% point. So more than 70% of the patients in the sample come from these two types of insurance. And I can represent this data in a different way. From the Pareto plot, drop down, go to pie chart. And the pie chart is showing proportions of different types of insurance. I can go back from pie chart to Pareto chart. Here we can use filter to show different groups. For example, we do have different groups as male, female. So if I apply a local data filter and add gender to the filter, clicking on female and male will present per the chart for each group. I can clear the filter to have both groups together. I can save this with the filter as a script. But this time I have to save a script for all objects to data table. We can apply the filter to different distributions the same way. For example, for distribution of amount, we'll run the script. If we add a local data filter, we can see the distribution of amount paid for different groups. For example, people who had a private attorney versus those who didn't. Here I have two levels of the category, not private and private. You can see the summary statistics and distribution. Those with not private, the average is 29,750. With private attorney, the average pay is over 122K. We can also do one-way analysis under fit y by x in order to observe side-by-side distributions, the box plots. Under this platform, we need two variables, x and y. So if the amount is a response, and for example, private attorney is the factor, we're going to observe the effect of private attorney on amount as a factor, see if there's any effect of this factor on the amount paid. And we can do different things, including just observing the distribution. Click OK. This is the base platform for two variables. Under this red drop-down, there's a group of tests. We'll click on the first one, quantiles, and we'll see box plots and distributions. Based on this observation, we can see those patients who did not have a private attorney on the case, they have a much lower mean comparing to those who had private attorney. Even though some of those with no private attorney received payment more than some people who had private attorney on the case. Now we can save this window and check the difference of these two groups across a third variable, gender. First, we will save this window as a script. Script to data table. Graph Builder can help us doing this. On a Graph Builder, we do a similar thing. Amount is on vertical axis Y, gender on X. Since this is a categorical variable, we can click on box plots to see the distribution of both groups, female and male. You can right click and add points to observe all those points. Now we can add the third variable. Under the top box, group X, we can group based on the third variable. So if we drop private attorney into this box, it will split the graph into two different graphs. Now we can compare the female group who did not have a private attorney comparing to the female group with private attorney received considerably less payment, and the male group with no private attorney comparing to the male group with private attorney received less. Both distributions can tell us that having a private attorney on the case is a significant factor in receiving higher payments. We'll save this script. Now, go to the file and see on the columns panel, you can see two asterisks. If you click on them, you can see value labels for private attorney and marital status. Any of the values in private attorney and marital status, if you double click them, you will see there are numbers behind the text. So private under private attorney is actually 1 and non-private 0. So the text we can see here is just a label. For the marital status, you can see numbers. Married, for example, is 2, single is 1, unknown is 4, etc. How we can do that? These are transformation of the numbers into text so that it can make more sense for the user. If you have Excel file or any other format you want to enter into JMP or any other statistical software, you can usually do this by labeling. And if you save this file as Excel, those labels are gone. We're going to do this process and see how we can add the labels. So we'll save this file as Excel. Change the type to Excel workbook. Medical malpractice. And save. There's a warning, some information will be lost. Okay. And go open that Excel file. In this Excel file, we can see private attorney is all numbers, marital status, all numbers. Let's say we're going to import this file into JMP. So we can import or copy paste. Select all. If you click anywhere in Excel file on any of the cells in the table, Control A selects all, Control C, copy into clipboard. Then we can create a new data table. Go to Edit menu, paste with column names. For private attorney, we apply the labels. Right-click on the header. Column properties, value labels. Here value 1, this label is private. Add, and value 0, label is not private. And add. Apply and OK. So we can see labels are applied. Do the same for marital status. Right-click on the header, column properties and value labels. Value 0. It's divorced. Add it. Value 1 is single. And add. Value 2 is married, 3 is widowed, and 4 is unknown. After adding all, you apply them and OK. So we do have all values, and as you see, those two asterisks are added here as value labels. You can directly get into value labels by clicking on them. And one more step, the data type. The modeling type of variables should be consistent with what we had. For example, marital status comes in as number codes, but it should be a nominal value. So click on this icon and make it nominal. For private attorney, 1 and 0, we have to change this to a nominal value as well. Severity must be ordinal. So we'll click on icon and make it ordinal. For ordinal values, we have to make sure that the order of the values is exactly as we intend. So we can go to severity, right click, get into column properties, and value ordering. Since this is the sequence of 1 through 9, it's ordered automatically, but then we can change them. For example, if we intend something else for the order, or for example, 1 should be the highest, 9 should be the lowest, we have to reverse the order. We can always select one or more of these by holding the Control key and then move them up or down. Now we can answer many questions. For example, what percentage of the people have private insurance? If you have saved your distribution, you can use it. Otherwise, that's easy to run a distribution. The type of insurance we have, that's a categorical variable. And we can easily see them. Private insurance accounts for about 43% of people. And as you see, selecting any group either on distribution, on the chart, or the table will select them everywhere. This is dynamic plot linking. If I select, for example, private insurance group, all those rows with private are selected on the table. Here as well, on frequencies for the group of unknown. If I select it here, every row that shows unknown insurance will be selected.